Hi, I'm Vedant, and I'm from Wilcox High School in Santa Clara, and this is my second milestone, which was to assemble the whole bot chassis and all the different parts that came with it. So the ultrasonic sensor, camera, motors, Raspberry Pi, and the battery packs. So to start this process, I installed the Raspberry Pi and the breadboard, and I mounted them with adhesive and hot glue. I also assembled the base kit, and then I put on the motor driver, the camera, and then I plugged in the ultrasonic sensor. So basically, how this robot works is the different parts, so the camera, the ultrasonic sensor, and the motor driver take commands from the Raspberry Pi. The motor driver is powered by these batteries, which are connected to the switch on the bottom. So I can use the switch to easily turn on and off the bot. And the Raspberry Pi is powered by this battery pack in the back of the bot. The weight is kind of balanced. So since the battery pack is heavy, the bot would tip over sometimes, which is one of the challenges that I face. So I balanced the weight so the bot wouldn't tip over to the side of the battery pack. But basically, the ultrasonic sensor detects distance by emitting sound waves and timing when they come back. So you could compare that to echolocation. And for the camera, I use a Python library called PyCamera. So PyCamera basically allows me to use various functions that they've made for Raspberry Pi users to capture images. So I can just show an example of that right now. So if I turn the camera to the side of the room and I run this program to capture an image, it'll take a little bit because it has to the camera captures the image and then processes it and then makes it into a file, which is viewable here. So I've taken the picture and it'll load, and as you can see, it takes the picture of what it sees on the side right there, which is the table and the rest of the room. So another example that I can show is an example of how the ultrasonic sensor works. If I just kind of move this wiring out of the way and I run the program, so it'll move forward until it detects an object in front of it, like my hand, and then it'll stop moving. So like that. So those are just two example programs I made to kind of demo the various parts of the bot. Some of the main challenges I faced during this process were the wiring. So you can probably tell that the wiring's a bit messy. There's a lot of longer kind of wires just hanging off the sides of the bot, and there's a lot of wires entangled in each other. So in the future milestones, I look forward to kind of rewiring it and making it look neater. Another challenge was the soldering of the switch on the bottom of the bot. So the switch that the robot came with didn't work. So I had to use a different switch, which wasn't meant for this bot. So I kind of had to bounce it on the bottom and do some really small solder connections on there. So that was another challenge I faced. And then of course, this is my first time coding a Raspberry Pi. I've used Python itself before, but I've never programmed an actual Raspberry Pi. So that was another challenging part. And for my next milestone, I look forward to actually implementing the tracking of the ball. So it'll follow the red ball around using the distance sensor and the camera. And then after that, I'll make some modifications where instead of detecting the red ball, it'll pick up small pieces of trash and detect those. Yeah, that'll be my modification milestone. Thank you.